Ladies and gentlemen, this is Miss Humber here. Today we're going to be doing Unit 7 Learning Target 11. So we're going to be talking about independent probabilities. So let's first kind of remember what we talked about in probabilities in general. So a fair number Q is rolled. So we want to find the probability of each of the following that are going to be happening. So first of all, we want to find the probability of rolling a 2. Well, let's think about it logically, okay? If we have 6 total numbers on a dice, only one of them is going to be a 2. So the probability is 1 over 2, which is 0.167. Now remember, we could also round that to be 0.17. Remember, if that third number is 5 or greater, you're going to round up. Next, taking a look at finding the probability that P is an even number. So of the 6 total numbers on the dice, we have 2, 4, and 6. So we have 3 even numbers. That reduces to the fraction 1/2. Well, 1 divided by 2 is 0.5. So there's 0.5 is the probability for that one. Next, finding the probability that it's prime. Well, what numbers are prime? Actually, 2 is a prime number. 2 is the only even number that is prime. 2, 3, and 5 are all prime numbers. 1 is not a prime number. 2, 3, and 5 are. So then let's go ahead and let's take a look. So then there's 3 numbers on the dice that are prime out of the 6 total. That's going to reduce to 1/2, and that's equal to 0.5. And that's our final answer for letter C. Next, let's take a look at number 2. So number 2 says that a fair number cube is rolled, and we want to find the probability of each of the following. So rolling 2 fours. So the probability of rolling the 4 on the first dice is 1 over 6. The probability of rolling a 4 on the second dice, again, is 1 over 6. So what can we do with those two probabilities to calculate the total probabilities is to multiply them together. So then 1 times 1 is 1. 6 times 6 is 36. So then the probability is 1 over 36. You divide that out and you get 0.03. So if I'm rolling 2 dice, the probability of getting a 4 on each is 0.03, or about 3%. Next, find the probability of getting a 2. Well, there's one way out of the 6 that we can get a 2. And then getting a 3, again, there's one way out of 6 that we can get a 3. So we don't want to think of it, oh, I rolled a 2 on the previous one, so it's less likely I'm going to roll a 2 on the second one. We can't think that way. Every single time we roll, it's equally likely that we're going to roll that number again. So we're going to multiply across. So 1 times 1 is 1, and 6 times 6 is 36. So then we have 1 over 36, which is equal to 0.03. So then again, our probability is about 3% of that happening. So we want to find the probability of rolling a 1 and then any number. Well, the probability of rolling a 1 is still 1 over 6. Then the probability of rolling any number, well, there's 6 total, and if we're going to roll any number, then we can roll any 6 of them. So our number of successes is actually 6. So we're going to have that fraction 6 over 6. So then you're going to multiply across. Then you get 6, and on the bottom, 6 times 6 is 36. Then you're going to reduce that to be 1 over 6. And then that's going to be 0.17. Okay, or 0.167, which you can round to 0.17. Either way, so then there's a 17% chance of that happening, especially since it doesn't matter what number we roll the second time around. So let's talk about probability. So first, let's kind of remember what we talked about probability initially, and that was that the number of successful outcomes divided by the number of total possible outcomes. So you have successes over total. So the probability of rolling a 4 on a dice is 1 over 6. Okay? Taking a look at these independent events. The result of one independent event has no impact on the other event. So for example, when we were rolling a dice and then we were rolling it again, what we did first had no effect on what we were doing after that. Next would be rolling a dice and drawing from a standard deck of cards. Do the dice and the cards relate? No, they're a completely different thing. They're separate. That's what makes them independent. Okay, so remember, when you see the word and tells you you need to multiply. So if you're reading through a probability problem and it says and it's talking about 2 probabilities and there's an and in the middle, then you know you need to multiply those 2 probabilities. So let's take a look at this first one. So, at a picnic, Julio reaches into an ice-filled cooler containing 8 regular soft drinks and 5 diet soft drinks. Well, I'm just going to do myself a favor right now and add those together. So I know whatever it's going to be, there's going to be 11 total. He removes the can, then decides he's really not thirsty and puts it back. What is the probability that the next person to reach in the cooler both randomly select a regular soft drink? So this both right here really has the same connotation as that and idea. So I'm going to be multiplying. So the first person is going to come in and grab a regular soft drink, and the second person is going to come in and grab a regular soft drink. Now these two events don't affect each other because Julio put it back in. So the first time there's a probability there's 8 regular soft drinks out of 11. So he's going to take it, look at it, put it back in, and then, oops, not 11, this should be 13. Goodness gracious, Mrs. Humbert. So then he sees it, he doesn't want it, he puts it back in. So because he put it back in, there's still 8 regular soft drinks in there, and there's still 13 cans in there. So then, when you multiply fractions, you multiply across the top. So 8 times 8 is 64. 13 times 13 is 169. So now that we have this fraction, we're going to divide it out. I'm going to take 64 divided by 169, and I get 0.38 as my percentage points for number 3. Next, let's take a look at number 4. So for number 4, a cage contains 3 white and 6 brown hamsters. So what does that mean? That means I have 9 total hamsters. Maggie randomly selects one, puts it back. Okay, so the events aren't going to affect each other. And, okay, I need to multiply. Then randomly selects another. What is the probability both selections were white? Well, when she first starts out, 3 of her 9 were white. But then she's going to take it out. Okay, now I'm going to put it back in. And she's going to draw again. So we still have 9 total, and we still have 3 that are white. So now again, we're going to multiply across. 3 times 3 is 9. 9 times 9 is 81. And then we can divide out that fraction, and we end up getting 0.11. So there's about an 11% chance of us actually drawing out a white hamster both times. Next, let's take a look at number 5. So Mr. Peshman is randomly selecting students to come to the front of the board. There are 30 students, 14 of them are girls, and 16 of them are girls again. Well, let's make one of them boys. Okay, what is the probability that he will pick a girl and then a boy, assuming the students can be picked more than once? So first, let's find the probability of him selecting a girl. So if we do 16 plus 14, that's going to be 30. So there are 30 total students. 14 of them are girls. So they're going to come up to the board, they're going to do their thing, and then we're going to come back, so we're going to multiply. And now that person sits down, so now there's still 30 total students that could come back up to the board. Now we want to find the probability of it being a boy. Well, there's 16 of the 30 that are boys. So now we're going to multiply across. 14 times 16 is 224. Come on. And then 30 times 30 is 900. So we can take 224 divided by 900 and we get 0.25. So there's a 25% chance that we get a girl and then a boy. Next, let's take a look at number 6. So for number 6, what is the probability? So we're talking about a deck of cards. What is the probability that you draw a jack from a deck of cards, replace it and draw 7? So if this is tough for you to remember, pull out notes 10 when we went through all of the different parts of a deck of cards. Well, there's 4 jacks in a deck of cards out of 52 total cards. So we're going to take that card, we're going to see it's a jack, and we're going to put it back in. So there's that and it's being put back in. So that makes it independent. So we still have 52 cards. And then there are also 4 7s in the deck. So now again, we're going to multiply across the top. That's going to get us 16. And then 52 times 52 is 2,704. So now we're going to do 16 divided by 2,704. And when we do that, we get 0.01. Okay, so there's a 1% chance of us drawing a jack and a 7. That's a really small chance. That's why poker's so hard, because the probability is stacked against you. You're pretty much programmed to lose. Okay, so let's take a look now at number 7. What is the probability that you draw a spade? So a spade is one of the suits. So when you have one of the suits, that's 13. So 13 out of the 52 cards are a spade. So we're going to take that card out, see it's a spade, and then we're going to put it back in. So then we still have 52 cards in our deck. Then the probability of drawing a face card. Well, we learned on the previous note sheet that there are 12 face cards. So then we're going to multiply 13 times 12, which is 156. And then we're going to do 52 times 52 is 2,704. So then you're going to take 156 divided by 2,704. And that's going to give you 0.06. Okay, so 0.06, that means there's a 6% chance of you drawing out that card. Let's take a look at number 8. So for number 8, come on, there are 26 candies in a bowl. So 6 Starbursts, 10 Snickers, and 10 Reese's. What is the probability that Miss Hummer draws out a Starburst? Which is true. I don't really like Starburst, so I probably would put it back. Call me crazy, okay? So there's 26 total Starbursts. Or total candies. 6 of them are Starbursts. So I'm going to reach in there. I'm going to say it's a Starburst, and Starbursts are icky. So I'm going to put it back in. So then there's still 26 candy. Notice that and there. That means we're going to be multiplying. Then draws the Reese's. Now Reese's are my favorite. So if anyone want to make Miss Humbert real happy, you bring her in a Reese's. Okay. So then we can multiply. So 6 times 10 is 60. And then 26 times 26 is 676. So now we're going to take 60 and we're going to divide 676. And when you do that, you get 0.09. Okay, so that means there's about a 9% chance of that situation actually occurring. So again, not so likely. Let's take a look at this last problem here. So for the last problem, Mrs. Johnson now is picking a new pair of socks at Target. Ms. Johnson loves some nice socks, that's for sure. So next, there are 6 different designs. So that means there's 6 total. So what is the probability that she pulls out a zebra design? Well, only one of the 6 is going to be zebra design. And well, she's putting it back, so we still have 6 socks to choose from. And then she's going to pull out a leopard design. Well, there's only one that's leopard. So 1 times 1 is 1. 6 times 6 is 36. So then 1 divided by 36 is 0.03. Now remember that 0.03 is the same as 3%. So it's not very likely at all that she is going to be getting her socks in that order. So that concludes your note for today. Go ahead and show me your completed note sheet once you're done. Thanks for listening.